Chapter 4 is displaying and summarizing quantitative data. The last chapter was categorical, so this one we get quantitative. The primary means of displaying quantitative data is by a histogram. So a histogram, they kind of look like a bar chart, but they're very different. All right, so I'm gonna draw a picture and then I would leave some space above it so that you can like write some stuff in, like definitions and just like showing what things are. So I'm going to. All right, so the left side is gonna be for frequency. And then the bottom, I'm going to count by fives. I'm going to start with 0, not like at the actual point here. So then it doesn't have to look exactly like this by any means, but I'm going to draw in some little boxes. And then if you want, you can just color them different colors. Doesn't really matter what they are, to be honest with you. Just like to make it look pretty. All right, so the x-axis is split into equal bins. which divide the numerical data into ranges. Okay, so each of these is a bin. And then notice that there are no gaps between the bins. So obviously there's a spot here, but basically what this is trying to say is that when you have them, they're touching. So like with the bar chart, we had space between them when we did them, but with these, you want them touching. The height, okay, of the bar or of the bin, whatever you want to call it, the height indicates the number of data values in each bin. And then for where you do have this gap here between 20 and 25 in this case, gaps are important. Don't eliminate them when a bin is empty. So if you don't have any data from 20 to 25, you still need to leave a gap for it. That's the only time you should have a gap. But don't like do 0 to 5 and then skip a little bit of space and then do 5 to 10 is what you don't want with when it says no gaps. Okay. And the nice thing is that your calculator can draw histograms for you and you put data into it, so it's a good thing to be able to have. Let's see. So something to note about histograms is that they can show frequency or relative frequency. Okay, so counts or percentages. The nice thing is that regardless of what you use, whether you just use frequency or relative frequency, is that either choice will create similar looking distributions. So all that means is that regardless of which option you choose, your histogram picture should look very similar. There should be the same gaps. If there's like data that you don't have or things like that. So I always like things to help remember, like little like acronyms to help me remember things. So when you describe a distribution, always remember your socks. Okay, without a K. So those are shape, outliers, center, and spread. And we'll talk more about each of those individually. But whenever you want to describe it or it's asking you for some kind of a conclusion or information about it, you want to talk about those 4 things. There's actually a whole chapter, I want to say it's chapter 5, it might be chapter 6, on outliers and what they are and all of that. So we won't spend as much time on outliers today, but we'll get the other 3 in this thing. So first, we'll talk about shape. So with that, we want to know, what does it look like? So is it, and this is what you're going to be deciding between. So there's going to be 4 pictures that we're going to draw here. So I'm going to set them up. They don't have to be like super big either. Just enough for you to see what we're drawing. So I'm going to draw them all and then we'll write under them what they each are. All those and then we'll talk about their names. All right, so the first one, if you look at it, you can see it just has this one little hump in it, but it's not like the same on both sides. This one is called Unimodal. The second one has 2 humps in it, so this one is called bimodal. Another name that you might see sometimes, or sometimes the way the book will write it, is actually multimodal. Because theoretically, I guess it could have more than 2, so, but those are the same thing. I would accept either one when you're writing them. The next one, they're pretty similar across the board. I mean, they're a little bit of height difference, but not enough to really be noticeable. This one is uniform. And then the last one, it's the same on the left as it is on the right. Okay, so it goes up evenly, comes down evenly. So this one is symmetric. So sometimes what'll happen is I'll give you one and like I'll have one like drawn out for you and I'll ask you what kind it is, or I may ask you on like a test to list and draw a picture of all 4 types or something like that. So anyways, something like this would be sufficient. They don't have to be like big or anything. So that's part of it when it comes to shape. There's one more thing that comes into the shape aspect of it, and that is it skewed? And so the way that we tell if it's left skewed or right skewed is that the tail points in the direction of the skew. So I'm going to do, again, 2 of these this time, because we have either left or right skewed. So I'm going to have something like this. And then when it's talking about the skew, okay, and when it says the tail, okay, what that's talking about is this direction and coming down here, okay, where it's basically getting shorter and all going toward one direction. So this first one, okay, the tail of it is on the left, so it's a left skew. And this other one, since it's on the right, is a right skew. Okay, and eventually that will tell us stuff about our mean or median. Well, it'll tell us what's going to be more accurate. So if we should use our mean or our median when we want to talk about the middle of the data, depending on if it's skewed or if it's like unimodal and symmetric, things like that. So all this will, right now, it's just kind of informational, what does it look like and all that. But later it'll tell us a lot more information about the things that we're doing. All right, so that's all for shape. So then outliers, like I said, we're kind of going to do just a quick little thing about outliers, and then in like either 5 or 6 or maybe both of them, we'll actually talk about how to decide what is an outlier mathematically. So outliers, data points that appear unusually small or large compared to the rest of the distribution. Okay, and then just note that not all distributions have outliers. Okay, so sometimes you might be given a set of data and it might say which of these points are outliers, or are any of these points outliers, or something like that. And so if it gives you data, then after we learn the stuff out of the next couple of chapters, you'll be able to actually mathematically tell if it's an outlier or not. But for right now, we're just going to be looking at a picture and determining what we think is an outlier. And sometimes when you don't have enough information, you may say, this looks like it could be an outlier, but I don't have enough information to say it for sure. And so sometimes we'll remove it if we think it's an outlier, it's going to affect the data. But if we do that, we have to note that we're removing it and why. So again, a lot of that'll come later, but it's just more of a little heads up about it. So just to get a little picture, if we have this little cube over here and then the rest of our data is over here. Okay, and then we have another little gap over here. So we have these 2 points that aren't directly touching the main part of our data. So this one over here, on the right hand side, okay, that one is close enough to our data. There's a little gap between, okay, but like we saw earlier, there can be a gap. It just tells you important information about the fact that there wasn't anything there. This one probably isn't an outlier. But this one over here, it's pretty far away from our data, and so we could assume that it is an outlier. So after outliers, we have the center. And the center is that we can estimate the mean and or median from a histogram. So, more as a refresher, because I'm sure you've heard this before. The mean is the average. So loud. It's the seniors too, isn't it? All right, so the mean is the average. So that can be written as the sum of x over n, okay, which means add up all the values and then divide that by the number of values you had, okay? So if you had a string of numbers, you would add up all the numbers and then divide it by how many numbers you had, and that's how you're going to get your mean. Again, your calculator is so lovely that it can actually do that for you. You just type it in and it just does it. And then because eventually, like, yes, you could manually type in each number and then divide it on your calculator, and that would give you your mean. But eventually you're going to need a lot more than the mean, and so your calculator can actually give you all that information by typing it in one time. So that's nice. And so when we're talking about it, you're commonly going to see the use of x with a bar over it. We'll call it x bar. That represents the mean of our data. The median is the middle value that separates the data into two equal-sized lists . So regardless of what the values are, whatever the middle number is always going to be your median. In some cases, your mean and your median will be the same number. In some cases, they'll be very similar numbers. In other cases, they will be polar opposite numbers, okay? It just depends, and ultimately we'll figure out which is the better one to use in different cases. So that's it for center. And then lastly, we have, find a different color. Nope, this one. We have the spread. So this is to state the minimum and maximum values for the data. And so again, another term you've probably heard before, but the range is the difference between the min and the max. And then another thing that's going to be new that you probably haven't seen before is that the data can be split into quartiles that indicate where each 25% of the data lies. Or each, did I say 20? I don't know. It's supposed to be 25. If I said 20, it's supposed to be 25. I don't know. Where each 25% of the data lies.
What are quartiles?
It's basically just the division of the data into smaller sections. And so, basically, you're going to have 3 things that are actually called quartiles, and then you have your min and your max. So you're looking at the area between each of them, and there's going to be 4 total of those. So I'm actually going to draw a picture here of them. So you're going to have, and you're going to need some space to write below them. So if you don't have a couple lines below them, I would start a new thing. But you're going to have the min, then your Q1, your Q2, your Q3, and then your max value. So after y'all write this, I'm going to turn it sideways to write some stuff so that it makes more sense. All right, so I'm going to turn it this way for just a second. Okay, so this is quartile 1. Then Q2 is quartile 2 or the median. And then Q3 is just quartile 3. I'm gonna flip it back now. All right, so then from your Q1 to your Q3, this area in between is called the interquartile range. And we're going to refer to that as IQR. So if you see IQR, think interquartile range. And what that's telling you is that the middle 50% of the distribution occurs here. So this is the middle 50% of the distribution. The area between the minimum and Q1 is going to be the lower quartile. And that contains the lower 25% of the data. And then from Q3 to your max is going to be the upper quartile, which contains the upper 25% of the data. So we get a lot of information out of this. Again, these are all 5 of these things are things that your calculator can actually tell you. Now the min and the max, like, you should be able to look at a list of numbers and say what the smallest and largest number are. But in terms of finding your Q1, Q2, and Q3, those are not necessarily the easiest thing to just look at and necessarily be able to tell exactly what they are. I mean, if you put all the numbers out and you list them all out, you could count and find the middle, and that's your Q2 and whatever. But your calculator can do it for you. Work smarter, not harder. So we'll do that on our calculator as well. So that all has to do with histograms and just describing our data. But we have a couple other ways that we can describe our display, our quantitative data. So, some other ways to display quantitative data. You may have seen these before. Maybe not this first one, but the second one, you probably will have at least seen at some point. Maybe not as well as elementary school, but probably at some point in middle school you saw it. So this first one is called a dot plot. And so this one, it's just, they're going to basically just be stacking number or little dots on top of each other to show you where data is occurring. Okay, and things like that. It doesn't look like it, but they are stacked on top of each other in a row. These are a little off. I was going to say, I was pretty sure that was Hope. So this right here is going to be your fastest way to display data. In some respects, it kind of looks like a histogram if you look at where the dots are lined up and stuff. But the other one is a stem and leaf plot. So that would be, you have the line and then you have different numbers on this side. So like 5, 4, 3, 2, 1. And then on the other side, you write the other numbers. So if I had the number 50, okay, the 5 is on the left, so I put a 0 in that row on the other side, okay? And so it's just another way to display it. So the numbers that I'm going to put here, I'm just making up numbers. And then there should be a key with it to show what it's wanting you to do. So the one that I used was 50, so 5, and then the slash and then the 0 represents the number 50. And so this again is the stem and leaf plot. And so it is visually similar to a histogram. The nice thing about it is that it preserves data values. So it's not just telling you that you have 3 numbers in the 10s or 3 numbers in the 20s. It actually tells you what they are. Okay, and if you don't see what I mean about it being visually similar to a histogram, if you turn it sideways, you can see that stacked up, it would kind of look like a histogram with the gap here at the 3 and then line it back up. So, all similar ways to display the data, but they all have their own unique things about them. So in terms of those, let me go back up here. So in terms of this min, Q1, Q2, Q3, and the max, that's what we call the 5-number summary. So the 5-number summary is a useful way to describe data so the way that it would be written is max, and it's going to just be listed as like this. So max Q3. Typically your calculator, rather than calling it Q2, it's going to call it the median. Depending on which version of the calculator you have, it might call it Q2 or median, but they both mean the same thing. And then Q1 and then min. So just a random set of numbers. The min 3.7, a Q1 of 6.6, a median of 7, a Q3 of 7.6, and a max of 9. Okay. In some cases, your min or your max value might be an outlier, but again, you'll find that out more once we go a little bit farther in this unit. But the function on your calculator is called one variable stats. So one variable stats on your calculator will give you this data. So basically, just kind of a quick, like, what is going to happen with that. When you have one variable stats, first you have to put all the number that you have your data into a list, and then you're going to have a button that, and sometimes it's like, there's so many buttons that we use in here, so sometimes it takes a little bit to remember exactly what you're doing. So a lot of times when we start doing examples and stuff, I'll actually write out the buttons in order that you need to push so that you have something to refer back to. But anyways, you'll push a button and it'll bring up the option for one variable stats, and then you'll have it run it out of the list that you give it, and then it'll come up and give you all this information, plus a few more things that you may or may not actually want to know. All right, next thing is standard deviation. So the standard deviation which you may or may not have seen before. Depending on some of the algebra books, we'll talk about it briefly, but the standard deviation is an important way to describe the average spread of the data from the mean. So in general, when we say standard deviation, we want to think of distance from the mean. So then I'm going to give you a couple formulas for standard deviation, and then also for one other thing. So this first one, S squared, okay, and this is actually going to mean variance, okay? So this is variance. And that'll be important later, but right now I'm just giving you formulas, and then it'll again come up more later. But is equal to the summation of x minus x bar squared all over n minus 1. Okay. Then your standard deviation. You're gonna steal my thunder. No, you actually don't have to memorize them. It's something that would be given to you. When you get to the AP exam, there's a list of formulas, and I actually I looked for it many times last year so that I would kind of know. But at the end of last year, I finally found on the AP site, it's a pain to deal with. Anyways, finally found a list of the formulas that they actually give you in your AP packet when you go to take your exam. So, no, you do not have to memorize this formula. But that was helpful because then I kind of knew like what I needed them to memorize and what I didn't need them to memorize. So, but standard deviation is just the square root of variance. So it's literally just the square root of this equation here. So. So then just something to give you kind of a visual of standard deviation. If this is your mean, and I'm going to do 2 of them. Whoa, that's crooked. If you had numbers that are all around your mean here, this will have a small standard deviation. And typically standard deviation I'm going to abbreviate as SD. So if you see that, that's all that means. There's different notations in terms of the symbol that represents it in math. It can be a sigma, it can be a little s, and sometimes it depends on what you're dealing with. But again, that comes more later. But that one would have a small standard deviation. If you had something where it's kind of all over the place, like that, okay, that has a large standard deviation. So you might be looking at this formula and thinking, what in the world do I plug into this formula? Well, I have some good news for you. We don't calculate standard deviation by hand. Use a calculator or some kind of calculator technology to do this. There's only a couple minutes, and I don't think we'd get to this last little bit, and I'd rather just do this all at the same time. So we're just going to stop there for today, and we'll do the last little bit of notes tomorrow. And then, assuming some printer on campus decides that it wants to print, I'll give you the worksheet that goes with it, and we'll work through that.